Good morning, everyone. Today, we are going to discuss one of the most exciting and colorful parts of food science, food colors and pigments. Think about your favorite foods for a moment. A fresh green salad, a bright orange mango, or a glass of red grape juice. What makes them look so appealing? It's the natural pigments present in them. Color is one of the first things we notice about food. It affects our perception of freshness, flavor, and even quality. Imagine a brown-colored milk. Even if it's safe, would you drink it? Probably not. Now, let's explore the natural pigments that give food its beautiful appearance. First up is chlorophyll, the pigment that makes plants green. Function in plants. It captures light energy for photosynthesis. Types. There are two major types. Chlorophyll A, blue-green, chlorophyll B, yellow-green. When you boil green vegetables, sometimes they lose their bright green color and turn dull olive brown. This is because chlorophyll loses magnesium during heating, forming pheophytin, which is brownish green. To preserve green color, blanch vegetables quickly and avoid overcooking. Cooking in slightly alkaline water, like adding a pinch of baking soda, keeps them green but may destroy vitamins, so not recommended. Have you ever seen green peas turn yellowish after long cooking? That's chlorophyll breakdown in action. Next, we have carotenoids, the yellow, orange, and red pigments. Carotenoids are relatively stable during cooking, but prolonged heating can cause some oxidation and color fading. Exposure to light and oxygen can also bleach carotenoids over time. Lycopene in cooked tomato products, like ketchup, is more bioavailable than in raw tomatoes. Cooking actually makes it easier for your body to absorb. Finally, we have anthocyanins, the red, blue, and purple pigments. Anthocyanins are pH sensitive. In acidic pH, they are red. In alkaline pH, they turn bluish-green. If you add lemon juice to purple cabbage water, it turns bright pink. If you add baking soda, it turns blue-green. Highly sensitive to heat and light. Prolonged cooking may cause fading or browning. Presence of metal ions, like iron, copper, can also discolor them. So, if you want to preserve anthocyanin color in fruit juices, keep them cold, dark, and acidic. Let's summarize what happens when we process foods. Chlorophyll loses green color, forms pheophytin, brownish on heating. Carotenoids, fairly stable but long cooking or oxygen exposure can cause fading. Anthocyanins, very sensitive, change color with pH, fade with heat light. So, food scientists must design processing conditions that retain maximum color and appeal. Sometimes natural colors are lost during processing, but consumers still expect food to look appealing. That's where artificial colorants come in. All right, let's recap what we learned today. Chlorophyll gives green color but is sensitive to heat, phaeophytin formation. Carotenoids give yellow, orange, red colors, relatively stable. Some are provitamin A. Anthocyanins are pH-sensitive pigments giving red, purple, blue colors. Processing can degrade pigments, so food technologists work to retain colors. Artificial colors are added to restore standardized color but are regulated strictly. Next class, we will explore food flavors and aroma compounds, how they are formed, lost, and enhanced during cooking.